Dynamic NAT overload. In this video, I'm going to talk about dynamic NAT overload or PAT. We call it port address translation or dynamic NAT overload. In the previous videos, you saw that I talked about the static NAT and also dynamic NAT. A static NAT means, for example, relation, a one-to-one with the between the private IP and public IP. And in dynamic NAT, we can use multiple for multiple private IP, only one or less public IP, but not simultaneously. This is not a good solution for shortage of the IPv4 address. The last solution, the best solution, is using the dynamic NAT overload. In dynamic NAT overload, finally, we can use only one public IP address for communication of the many private IP address with the for example, public network. Let me to show you how we can use the dynamic NAT overload to reach this goal. Okay, let me to show you. Here, assume that we have a router R1. This is the NAT device. And also, we have only, for example, one public IP address. This is the one public IP address. 100, for example, 10. And we need to use this public IP address to communicate with the public network. Okay, and also we have, for example, three PCs with private IP address. The PC1's IP address is 192.168.110/24, and the PC2 192.168.1 for example 111.112, and then for PC3 we have 192.168.113/24. Now I'm going to show you how we can use only with one public IP address and for communication between the PCs and also the private network and also the public network. First, we should review the topics in the TCP/IP. You know that in TCP/IP, we are using the transport layer port for communicating with the system inside, with the protocol inside of a system. Assume that we have, for example, two PC1 and server 1. Okay, in server 1, we need to communicate with the, for example, protocol HTTP. Okay, and because of that, PC1 should send the traffic with the source IP of IP1. IP1 is the IP of the PC1 to destination of IPS. This is the this is the IP address of the server, and this packet now can reach to the server. But the problem is that which application you want to work with it on the server. You know that if I want to choose the application, I should use the port. Okay, for example, assume that in this server we have many protocols, HTTP or Telnet or SSH or some other protocols. Which protocol do you want to communicate with that protocol? You should use the port. Okay, for example, if you are using the TCP/IP, application should send its traffic to the transport layer protocol, and then transport should encapsulate the packet and should send to the IP protocol or network layer. Okay, the protocol of the application, assume that is HTTP, and the transport is, for example, TCP or UDP. The network is IP protocol. Okay, because this is a request of web, I need to use a GET request. This is the HTTP request, and giving this request to the TCP. TCP should add, for example, source port and destination port to this packet. GET request now is encapsulated with a random port, for example, 50,000, to the, for example, well-known port 80. This is the port of the HTTP, and then we should send we should give this packet to the IP, and after that IP should again encapsulate this packet with this is the source port 50,000 and destination port is 18, and then IP should use the IP1 as the source IP and IPS as a destination IP. Okay, this packet can reach to the server, and server, after comparing the destination IP with the IP of itself, can understand that this packet received for itself. And after that, it should check the destination IP, and finally, with the destination IP, server can understand that this packet should send to the HTTP protocol, for example. Okay. But for now, I want to use the source port for another things. You know that the source port, when you request a service from an application, is a random port, okay, dynamically assigned port. We can use this dynamically assigned port and combine it with the IP address to solve the problem of shortage of IPv4 address with dynamic NAT overload. Let me to show you how we can use the dynamic, okay, NAT overload. We can use one example here. Is the scenario, and I'm going to show you how we can use the dynamic NAT overload. For example, PC1 now wants to send traffic, okay, to the for example one server. This is our scenario. PC1 connected to R1, PC2, PC3 also are connected to the R1. Then PC1 wants to send traffic. The source IP of the traffic is 192.168.111, and also the source port is a random port. The combination of the source port and the combination of the IP and port, okay, is called the socket. This is the socket, okay. The socket of the PC1 is the source combination of the source IP and also source port. 192.168.111 is the source IP, and 50,000 is source port. Okay. Then the destination IP is the IP of the, for example, say the server. Assume that this is the IPS. It's not important for us, and destination port is a well-known port, 80, for example, for HTTP. Okay, this packet now can reach to router 1, and also we have another packets received from the PC2 and also PC3, 112 and 113. Okay, assume that all of this traffic should go to one server or different server. It's not important for us. IP server 1, IP server 2, IP server 3 for same application or different application. It's not important for us. Only the source IP and source port is important for us. Now these packets can reach to the these packets received in the R1, and you know that because the source port is random. For example, one of these packets can use 50,000 as the source port, and other packets use 50,001 as the source port, and maybe one other system use again the 50,000. It's not important. This is random. Okay. When the packet reaches to the R1, R1 only has one public IP address, and it wants to use this one public IP address to NAT. How we can use one public IP for many systems, for many private IP address? You know that, for example, if we only use the translation of the, for example, IP to IP, private IP to public IP, assume that when we use the for example, translation of IP, I can translate the 192.168.111 to 100.10, okay, to destination of IP S1. If I don't use the, for example, port, again, we should use these translations. All of this IP address should all of this private IP address should translate it to one public IP address, and this is not possible. Why? Because when the traffic sends back to R1, R1 can't understand which destination IP at the response should translate to which destination private IP. Because of that, we need another things to solve the problem, and that is the port number. When the packet reaches to the R1, when you are using the dynamic NAT overload, R1 uses source IP and also source port for NAT.